Chapter 8 is about linear regression analysis. In the previous chapter, we learned that how to understand the relationship between two variables, x and y, how they are related positively or negatively, uh, whether this relationship is strong or weak. So these two things we can, if we need these two things, we can use correlation method. But we extend this correlation with regression. Let's see what extra we can do with regression. So regression. Now here we calculate and interpret the simple linear regression equation. Now in correlation that equation was not possible. In correlation we have a dependent variable y and we have independent variable x. So we find certain relationship. But here we will convert it into a kind of equation. So y equation is important because if we know the value of x, we can calculate the value of y. In correlation, it was not possible. It shows only the relationship, but there is nothing. We cannot calculate if one value is given. We could not calculate the value of dependent variable. So with the help of this regression analysis, we will create a equation based on the set of data. We will have certain assumptions behind regression model. Also we will test the hypothesis based on regression whether this relationship is significant or not. Also we'll try to know what is confidence interval of regression and the various applications and prediction and description. So yes, with the help of regression, we can predict. As I said that we always create an equation, and with the help of this, we can easily predict the future. With the help of various x value, we can find y value and explain it the changes in an independent variable on the dependent variable. So the changes in an if there is any change in this independent variable on the dependent variable. So we already know what is independent and independent variable. So in simple, so now linear regression, there are few things. Regression means the relationship between x and y. Linear. Now regression can be linear and non-linear. So here we'll study only linear regression. And this linear can be simple and multiple. Now what does it mean? What is the meaning of simple and multiple? Multiple we'll study later on. So if y is a function of x, means only one independent variable, then we call it simple. But suppose y is a function of more than one independent variable, x2, x3 and so on, then we call it multiple. So here first we learn simple linear regression where we have only one independent variable and then find the relationship between x and y with the linear function. So please understand the meaning of each and everything. Simple means only one independent variable, linear means a linear function, and then we'll try to create a relationship between y and x. So same thing almost which we have already know about the relationship in the correlation. So if the line is going upward, we call it positive. If line is going down, we call it negative. If the points are very near, we say they're strong. If when points are far away, we call it weak relationship. So here almost both are strong but positive and negative. But instead of line, if we get a curve, we call it non-linear or curvilinear. So we'll study here only the linear relationship. And if we get a horizontal line, we say no correlation. So these are the certain things which is almost same like in correlation. Now how to convert these relationship, these sample data into or the population data into regression equation. So this is the regression equation where y is a dependent variable. This beta 0, beta 1 is a constant. These are the constant. This beta 0 is called intercept. Please remember this beta 0 is called intercept. And we are talking first about population. And beta 1 is called slope. X is independent variable. This is dependent variable. And this eta is called the error. Now, when we transform it into with the help of certain assumptions that the error values are statistically independent, error values are normally distributed, the probability distribution of the error is normal. So basically the assumption is near about everything is normally distribution, equal variance, and the relationship is linear. So if these assumptions are there, then we can easily understand this population linear regression. Suppose these are the points based on the x and y values given data, and we have to draw a line. So this is what, when we draw a line, that all these distance is called error. You know, larger the distance, larger the error. Okay, and this angle is called slope, and this line where it is intersect is y-axis is called intercept. It is denoted by beta 0, and this slope is denoted by beta 1. So we are looking for these two constant. Now when we convert, actually the regression analysis is done based on sample. When we collect certain sample, and then we have to convert it into a regression equation. Now this is what we have to focus now. The previous was purely theoretical. Now this you should know that how to create a regression linear equation or regression line, simply regression line. So here we call it y cap. So it is written as y because we are using a sample. So we call it y cap, and there instead of, in population we call it beta. The constants are beta. Here in sample it is known as b0 and b1. Right? So please remember b0 and b1. Remember again, y is a dependent variable, x is independent variable, beta 0 is called intercept, and beta b1 b0 is called intercept, and b1 is called slope. Our main objective is to find the values of b0 and b1. If we get these two values, we can create our linear line. How to calculate these values b0 and b1? For that we have to use one method called minimize the sum of square residuals. These are called residuals, or square of residuals, and with the help of this we formulate the value of b1 and b0. So finally you have to remember these things now. So what we are trying, we are looking a linear line, regression line, which looks like that. Y cap is equal to b0 plus b1x. And how to calculate? So we need to find out the values. These are constant. How to calculate b1? This is the formula, direct formula and shortcut formula. So any one of this you can use, either this or this, both are valid. So this is direct based on mean. If you want to calculate mean, yes, use this, or indirect or shortcut method without calculating any mean, you can calculate b1. So like in correlation, we had two different methods or different formula. Both are applicable earlier in the correlation, and these two are applicable here. So when you get value of B1 either from this and this, calculate the value of B0 with a very simple formula. B0 is equal to mean of Y minus B1, which is already calculated here, multiplied by mean of X. So what it signifies, as I said, this is called slope is known as b1 and intercept is called b0. So it signifies b0 is the estimated average value of y when x is 0, because we know y cap is equal to b0 plus b1 x. So what is b0 when x becomes 0? So the value of b0 is equal to y. What is b1? It is a estimated change in the average value and known as slope. So these are the things you have to remember theoretically. Now, how we calculate B0 and B1? So when it is a simple regression, yes, manually we can calculate. Otherwise, we have so many, tools and techniques, software by which we can do some regression analysis. So first we will learn how to do it manually. If it is a simple regression, multiple regression, yes, you have to use these softwares. Let's see one example and manually we'll calculate it. Now here they are saying that there are two variables y and x. Y represent house price and independent variable x is represent square feet. So there is a relationship between here, the price and the square feet. Now please remember, before we start regression or any other analysis, please clarify which one is x, which one is y. You can write x here or here, no problem, but you should know that these are the value of y and these are the value of x. Let's start solving it with the help of shortcut method. So what we need in the shortcut method, we need few things. Let's see what we need. We need sigma xy, we need sigma x, we need sigma y, we need sigma x square, we need sigma x whole square, and we need n. So these are the things. So please I remember sample size, sum of x, sum of y, sum of x into y, and sum of x square. So these are the requirement and we'll do it one by one here. So what we need first n is count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure that there's nothing like n1 and n2. It should be same. And then we need sigma, we need sigma x square and sigma xy and sigma y and 6. So we'll add it here, sum here. So sum of y is, if you add it, you'll find 2865. If you add x, all x, you'll get 17150. And now we'll do x square. We'll multiply 1 by 1, square this, so it will come to 1960000 and so on. So you have to be careful whether these values are correct or not. Calculate in a proper way. So I'll write one by one all the square. Then we have 1210000. We have 2402500. Then we have 5522500. And we have 62500, 2030625, and finally 2890000. So these are the square value of x and we'll add it. So we'll get 30983750. Same way we'll multiply y with x and we get certain values. 343000, 499200, 474300, 577500, 218900, 339450, 951750, 454575 and finally 43350. These are the values. We'll add it. We'll get 5085975. So remember, this value will represent sigma y, this value will represent sigma x, this will represent sigma x square, and this will represent sigma xy. Now with the help of the formula B0, we will calculate the value of B0. Now if you go back and see, the B0 means sigma xy minus sigma x into sigma y divided by n whole divided by sigma x square minus sigma x whole square n. I will put all these value in this formula and we find it. I'm writing in a little bit smaller number so I can solve everything here, right? This is the sum of sigma xy minus sigma of y sigma x, you can write in any order, sigma x 17150 divided by 10 whole divided by, make sure you understand the values here, this value sigma x square 30983,750 minus, you know, sigma x square, that is 17150 whole square divided by 10. So we'll calculate it and let's see what value comes. Give me 1 minute. So I put it like 0.1098 something B0. Now based on this we'll calculate, uh, sorry, this is B1, make sure this is B1, we are calculating B1. Yeah, yes, B1, actually we are using this formula B1. Now we'll use B0, so it will be, I'll put it here somewhere here, B0, it is equal to the mean of y, so the total is 2865 divided by 10, so 2865 divided by 10, it will be divided by 10, the mean will be this, minus we will have the value of B1 0.1098 and multiply the mean of, oh this is y, okay, and then the mean of x, so we have x 17150 divided by 10, so 1715. So here we find the value. Now we can easily represent final answer will be y cap. This is linear line because always they ask you to create a linear line. For that you have to calculate value of b1 and b0. So the actual linear equation is b0 plus b1 x. So if we put all these value, y cap is equal to b0 is where 98.25, and then we have plus the value of b1 0.1098x. So this is your answer. Unless until you will not write this answer, you will not get the mark. So this is called linear line. Only solving this b0 and b1 will not give you the full marks. Now they will ask more question. You know, we put it, I hope it is clear that I put this b0 here, and this b1 here, and try to create a linear line. Now they will ask if the value of x is 20 or 30 or anything, they may ask you the if the value of x is 2000, suppose if the value if x is equal to 2000, what is the value of y? So how will you calculate? Just put y at 2000, 98.25 plus 0.1098 into 2000, and then you get the value of y when x is given equal to 2000, right? So this is all about your regression analysis, regression line, how to calculate coefficient. These are called coefficient. B0 and B1 are called coefficient, regression coefficient. And with the help of this, we have to find the regression line, and then you have to solve some more question if it is given various value of y. This is called prediction. So in case of this value is not given, we can predict that if the value of x is this, what should be the value of y. So this is the most important part of any analysis, statistical analysis. Yes, you need to know mean, median, mode, everything, standard deviation, and then on the basis of that you have to identify the relationship with the help of correlation, and finally to predict the value of dependent variable y with the help of x, you need a regression line. So this is a whole analysis which is very much required in statistics. Here you see one Excel output based on a regression analysis. There are actually three tables, so table 1, table 2 and table 3. Here you find this is called multiple R. Multiple R means correlation. If anybody asks what is the correlation between X and Y, so you just see this value and find the correlation. This is actually r square. Whatever is there, if it is not given, you can calculate square of this is called r square. Then there is a small improved r square without any error. So it is basically it is a better r square than this. We have some value of a standard error, and this is sample size n, right? 10. You know that earlier we have total sample size n. Now also here the table 2, it is called ANOVA analysis, analysis of variance, analysis of variance. So if you remember, we studied the variance in chapter 1. Now this is SS, sum of a square, this is mean of the square. And how we test it, we use F test. Earlier we were using Z test, T test, here we'll use F test. Now this is what we could write, a regression value. A residual means error value. So it is denoted by R, it is denoted by E, it is denoted by T. First we'll have a degree of freedom. This is the number 1, regression degree of freedom. It denotes the number of number of independent variables. So in simple regression there is only one x. So in simple regression the value will be 1. When we go to the multiple regression, there will be more uh, variables, independent variables, so that will increase. This value's total is actually n minus 1, right? And the remaining value, this plus this should be this is the total value always. So this plus this should be this. So 1 plus 8 is equal to 9, and it should be equal to n minus 1. Now this software will calculate some values. These are called SS, sum of the this values. And this is because this is first values, sum of the square of R. So this value is called SSR. This is a sum of square of residual or error. So this value is called SSC. Please remember, these are very important. And this value is called, this is SST. So this is called SST. So how to calculate this plus this should be this. So sum of SSR plus SSA is equal to SST. Same way, this value is called MSR. This value is known as MSE. And if you divide MSR with MSE, this divided by this, it will give you F. So what is F? F is equal to MSR divided by MSE. Now how to calculate MSR? MSR is equal to SSR divided by degree of freedom. This is equal to MSR is equal to SSR divided by its degree of freedom. Same way, this MSE is equal to SSE, this number, divided by its degree of freedom. So, degree of freedom. Here degree of freedom is this number, here degree of freedom is this number. So by this we calculate so many things and we analyze and we interpret at the end. Now what we are looking our B0 and B1. So these are the value of B0. If you remember, we calculate B0 around 98.24 and then we got B1 with the help of formula around 0.10 something 9. So you see, if you, directly you can check here and directly you can write your regression analysis. B0 is 98.24. I'm just putting okay, all the values here plus 0.10977x. So with directly, no, with the help of Excel, you can directly write your regression line. And this is what we have confidence interval at 95%. Confidence interval of B0 is this. Confidence interval of B1 is this. Right? We have some significance F value or P value. We'll talk later about this and what it denotes. We'll talk in test when we follow to test. So yes, manually as well as with the help of software, we can calculate all the regression coefficient and some other values which will help us to interpret the data. Now as you see that it is clearly here, the linear line is this. This is your B0, this is B1, this is your Y value or Y cap actually, and this is your X value. And this 98 is called intercept. So intercept means the value which it cut at y-axis, and this line, the angle of this line is called this one is slope. How much it is? It has angle. Now see, the B0 is 98. This is the equation, right? So this is the interpretation. So when there is, suppose there is no square fit, 0. So they are asking if there is no square fit, what is the value of house price? This one, 98 point this, only B0. And so on. If there is another value given X, you can calculate the value of house price. Right? So for example, if the average value of a house increased by this one, this is actually uh, this is the slope, and it represents that how much increase is there. So it increases by 0.10977 because square feet is given in thousand, so they are using it. Otherwise, slope tells that how much increase and decrease there in house price. SST is equal to SSE plus SSR. SSE means sum of SS means sum of square of error, right? SSR means sum of square of regression, and T means sum of square of total. These are the pictorial, with the help of chart and diagram, where we actually see these values SST, SSE and SSR, and then how to calculate. Suppose you need to calculate correlation R. So how to calculate? First, R square is equal to SSR divided by SST. If you take the square root it, you will find your value of R. And this will represent the correlation. So with the help of this table, yes, we can calculate the correlation by dividing SSR and SST, this one. And again, this is the same interpretation which we have done earlier in the correlation. Going up and down means positive or negative. If they are far away or near, strong and weak. If it is a horizontal line, then it is 0. And just see again, same interpretation is here available, where it's showing, all values are there. Correlation is there. R square, what R square? SSR divided by SST. So it is divided by this. If you take these two number and divide, you will get this value. So sometime in exam will not give you this value, will give you this value. So you have to divide and find the answer. This, I repeat, this is again number of independent variable, how many x values you have. This represent n minus 1, and this plus this should be equal to this. To test the regression, we have to find this f value. How to find this value? We need to know about this value, which is MSR, and this is called MSE. If we divide it, we find this divided by this is equal to f value. And how to get MSR? I repeat, this is equal to this divided by this. How to get MSE? This divided by this. And this, if you add this, you get the total of it. This will tell you whether that test is significant or not. For that, we need to check F table. Again, F table will be checked and check at the 95%, and you have to see the 95% value plus and minus, and see if this value is inside it, say no relation. If it is value here or here, say yes, there is a relation between x and y. So how to start this hypothesis? So HO is equal to 0. There is no relation. Does not explain, no significant relationship. If we accept this, means and reject outside of area, then say yes, there is a relationship. Yes. And for that, we need to calculate F value by dividing SSR by SSE and their degree of freedom. And if you see the F value of at 95% is 5 point. It is table value. Like we have a Z table, T table, we have a F table. Now in F table we have 2 degree of freedom. Number 1 this and number 2 this. So first degree of freedom 1 and 8. So we'll check at 1 and 8. Right? And we find that the table value is 5.38318. So we'll make a diagram here. At 95%, the value is minus 5.318 plus 5.318, and you see our value, F value. It is outside here. So we reject. What we do? We reject this and we accept this. And when we accept it, say yes, there is a relationship. So in this data, yes, it comes here. So there is a relation between x and y. Means I in x influence y. Independent variable influence the dependent variable. So there is a significant relationship between x and y. Correlation is this. Correlation square is this. Adjusted R square is this. And all values, please. That's why you have to see this table again and again to understand the confidence interval, the coefficients of regression, P0 and V1 and so on. So we have some practice question here based on the simple linear regression analysis. Now let's start with the first question. When a pair of variables means x and y, have a positive correlation, the slope in the regression will always be positive. Yes, because the positive correlation says the positive slope, because it goes to up. Up means positive. If it goes down, we say negative. So yes, true. In a simple regression model, the slope coefficient, I repeat what is they are talking about slope. So I write the equation again. Y is a kind dependent variable Then we have an intercept called B0, and then we have a slope called B1, and then we have a independent variable. So slope coefficient, they are talking about the slope coefficient B1 represents the average change in the independent variable for a 1 unit change in dependent. Now, basically, if you read it, yes, actually, slope shows the relationship, the change, average change in one variable to another. But why it is false? So represent the average change in independent variable. Actually, it shows the change in dependent variable. So otherwise, this line is correct, but they have written in the opposite direction, independent to dependent. It shows the relation, change in y, not change in x. So that's why it is false. Otherwise, statement is correct if it is written in opposite way. In developing a simple regression model, it is assumed that the distribution of error terms will be normal. Yes, this is one of the assumptions. That's why we use it, whatever formula we have. Yes, it is based on normal distribution. If a set of data contains no value of x, again you see there's no value. If it is not given, there's no value of x. So there's no regression actually. Has no meaning. Because without any x value, how can you use regression analysis? So that has no meaning. Now, let's see if it is your regression line. Predict the value when x is this. So in this, normally you have to calculate this is your B0, this is your B1, and then you create a linear regression. Now, very simply, when you get a line, what is the value of y when x is 40? So what they are asking value of y when 34.2 plus 19.3 multiplied by 40. Let's see whether this value is equal to 806 or not. Yes, so this value is equal to 806, so this statement is true. Same way we have, now in this question we'll see there are 30 customers, and there is a dependent variable. Again, monthly bill is dependent and number of square feet is independent. So this is your independent x, and this is y, this is n. Sample correlation is known to be positive. Yes, how to check if there is a positive or negative correlation? Yes, this value. The slope is, if it is up, say yes positive or negative. And same way, same question you see here, same regression line, 2000 square foot. Now this they are asking the value of 2000, and monthly is bill is 100. This is actually the again the formula residual from yes. So yes, with the help of this residual formula given at the end, we can calculate whether this value is equal to this or not. The average expected bill, same question they are asking and again, that again uh, the regression is this: the expected bill customer with home with 2003 square foot. Now you have to check this, put this value as x, this is your utility bill. So bill is y, and then they are asking square feet, this one. So put this square foot, it is x, and find whether this value comes y or not. So here you check, when you put this x here, you will not find the real value here. So that's why it is false. Now again, this is the output of Excel sheet. How to interpret it, again how to write a line here. Let's see if they are asking. So there may be hundred of questions, First question, what is the correlation? So immediately go here. It is your correlation, small r value. What is the square of the correlation? This is called r square. I tell you, maybe sometime they will write correlation or coefficient of correlation. of correlation. So suppose you have this table and the question is about what it is the coefficient of correlation between the two variables x and y. Just write this value. Second is r square. It is also a coefficient actually. Coefficient of determination. Please remember this is very important. Sometime this question is asked. Coefficient of determination. 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 It is denoted by r square, right? So this actually, if it is not given, square it. Suppose it is given, take the square root of this. Sometime these two, one of this will be missing here. So with the help of this, you can calculate and you can write coefficient of correlation is this, coefficient of determination is this. Adjusted r square and then standard error, then observation n. Now you see this observation here total will be n minus 1 here, right? In simple regression, because we, and here because we have only, it means there is a simple regression, simple linear, y is equal to only fx, or y cap is equal to b0 plus b1x, only one x variable, that's why it is 1. Remaining this plus 1 should be this. So with the help of this we can calculate. These values will be given, or any two of value will given, because this plus this should be equal to this. Suppose this value is not given, so add it. Suppose this value is not given, so this minus this will be this. So with the help of this relationship, this plus this, this is called regression and error and total, and this plus this is always equal to this total. Same way how to calculate, this is called SSR, SSE, SST. This is MSR and MSE. MSR is equal to this SSR divided by degree of freedom. MSE is equal to SSE divided by degree of freedom. And then finally F is equal to MSR divided by MSE, this divided by this. And then with the help of F table, we can check whether this value is significant or not. Sometimes we don't need to check it, because normally we check it at 5%, 5% or 95%. 5% means 0.05. So if you want to see table, yes, we can compare it with that F table. But sometime, if suppose we don't have F table, we can directly use this value. If this value significant F, and this is also called p value, so there's nothing, it is also called p value, and this is called z value, z alpha value. So how to check it? Same decision will come either from table or from direct p value. So this value, please remember, this value is less than 0.05. This value, if p value is less than 0.05, we say yes, there is a relation between x and y. If this value is more than 0.05, we say no. So here you see this value is less than 0.05, say yes, there is a relationship between x and y. Come here and write here b0, b1. If there are more variable, write b2, there will be more line. We'll see in next class in multiple regression. So b0 is this, b1 is this. So now question will be write the linear line, so regression line. How will you write? Simply y cap is equal to b0, 4.82, I'm taking 2 digits only, plus b1, 0.05 only, and x. This is our regression line. You can write full all digits, but in short we can write it. So we have everything here. You see everything we have here. We can we find the coefficient b0, b1. We can find the linear equation. We also test here with the help of p-value whether it is a significant relationship, yes or no. So here we would reject null, yes. So actually when it is, I said if it, here because p-value is less than this, so we reject the null hypothesis. Null hypothesis was, remember, that the regression coefficient is equal to 0. Null hypothesis, and regression coefficient alternative was beta 1 or beta simply because we have only one here, so that's why I'm writing beta is not equal to 0. So basically we reject this and we accept this and say yes, there is a correlation. So yes, this is true. In a simple regression, if the regression model is deemed to be statistically significant, it means that regression slope coefficient is significantly greater than 0. No, it is nothing now. The slope can be positive and slope can be negative. So it is not only greater than 0, it is not always positive. So it can be positive, it can be negative, it can be significant, it cannot be significant. So all possibilities are there. In the simple least square regression model is developed based on sample where two variables known to be positively correlated. The sign of regression will be positive. Yes, this sign, this is a positive sign, shows that yes, there is a positive. It shows, this is the slope. It shows that yes, there is a positive. If there is a positive correlation, it means there is a positive regression between these two. So this way, we use F test. Yes, you use F test. Now this we'll do this practice session here. So this is I write it what is all about question. So if you see there is a manufacturing company interested in predicting number of defects to be produced each hour. So this is your defects. Why? They would like to know, predict. So whatever we need to predict, it is Y. Production rate based on production rate X, right? Production defect per production rate per hour. The manager believes that they can use production rate to predict the number of defects. So whatever, remember, whatever we want to predict, it is denoted by Y because it is a dependent variable. Now what we would like to know, Y is equal to B0 plus B1X. The following data are collected 10 now. N is 10. Now we have to find out the regression line value of B0 and B1 and check whether these are equal to this or not. So as we know, this is our Y, this is X. To regression we need two more columns, two columns only we need. We need one column called X square and another column we call it Y only. And then slowly you calculate all these values. And then we'll find the sum of sum, total or sum. Here we'll find sigma y, sigma x square, and sigma xy. This is xy actually, xy. And with the help of these value, we'll try to calculate b1. And then we'll calculate b0, and we'll see whether these values are same or not. To calculate b1, we have a formula. Shortcut formula sigma xy minus we have sigma x multiplied by sigma y divided by sample size whole divided by sigma x square minus again sigma x whole square divided by n. B0 is equal to the mean of y minus B1, mean of x. So sigma y is equal to 235, correct? Sigma x, if you add it, 3725. Sigma x square, yes, sigma x square is 1418125. This is also correct. And sigma xy is 89000. Now put all these values here and see what is the value of B1. So if you put all these values here, sigma xy, sigma x, sigma y, and sigma x square, sigma x whole square divided by n, you'll find yes, B1 comes out 0.048, and then you calculate the mean of y and mean of x as well as, and put all these values here, you'll find that the B0 is 5.67. So yes, this equation here given, regression equation or regression line, is correct. It can be asked more question, if the value of x is this, calculate the value of y. Here suppose it is given x 400, 450. Suppose they add, if the production rate per hour is 500, suppose 500, they would like to predict what is the value of y here. So simply what you do, put all these things, y cap is 5.67 plus 0.048 multiplied by 500, and then if you come calculate, you'll find the value when the x value is 500. So yes, in regression equation, when y is, you have to calculate when x is 0.5. With the help of these regression coefficient, first make your regression line, and then put this x value, whatever value is given here, put it here, and find whether y, what is the value of y, and easily you can check your answer is right or wrong. Now other than this, yes, there are so many things we can calculate from this. As I said, coefficient of correlation, coefficient of determination, adjusted determination here, the standard error E, that number of objects n, right? Number of independent variable. So number of independent, this is your number of independent variable. Then SSR, SSE, SST, MSR, MSE, and F value. Now we have to check whether there is a relationship, significant relationship test. We'll test the hypothesis. So we'll see the HO means that there is a no relationship, beta is equal to 0, and then we'll write alternative, beta is not equal to 0. Let's see whether which one is correct. For that we need to check F table, and we'll find whether it is an acceptable region or rejection region. So I'll go and check, and before that check degree of freedom 1, 6. We need in regression 2 degree of freedom, 1, 6 at 95%. We'll check it and find out that there is a relationship or not. For that I will show you that F table. So based on these two degree of freedom 1 and 6 and 95, we have a table called F distribution table at 5%, 5%. So we'll not ask you any other percentage alpha, only this table is only for alpha is 0.05. Now check 1. So 1, 8, 1, 6. I go back and show you 1, 6. So 1, 6. So go this column 1 and this column 6. So which value you see here? What value you see here? 5.99. 1, 6. I write here from the table F value at 9.05, at 1, at 6 is equal to 5.99. So we'll write it here, two-tailed test minus plus 5.99 and 5.99. Now your value is 27, so it will come where? In rejection area. This is, so we reject null hypothesis. We reject this one and we'll accept this one. That beta is not equal to 0. So we reject our null hypothesis and do not reject our alternative hypothesis. It says, if we use, this says no relation, it says yes relation. So what we are accepting this. So yes, there is a relationship between x and y. Very clear. Here p-value is not given. Suppose p-value is given, p-value. So also directly you can use it, same thing, whether this p-value, whatever p-value is here, if it is less than 0.05, no? Again remember, same thing, you say yes, there is a relationship. If it is more than 0.05, say no, there is no correlation, no relationship.